Here are the answers for the construct the understanding ones and the work shown. And in this, I want to point out a bit of the strategy. So the strategy will be in solving an equation like this, get a common denominator. And they did that in their work right here. They noticed that between 3x4 and x, the common denominator would be 12x. And then you multiply by that common denominator, and it gets rid of all the fractions. So first, if we get a common denominator, then our rational equation still has fractions, but then if you multiplied everything by 12x, the 12x on the bottom would just go away. And it turns it into a much easier question to solve. That'll be our main strategy in this section where we're solving quadratic equations. I'm going to highlight this, copy it, and if we go to the next example as well, they did the same strategy. They looked between the two, the x plus 2 and the x minus 4. They got a common denominator. And then they multiplied by that common denominator, which one of the things you'll probably do when you multiply, you'll probably just stroke them out like that. Because when you multiply by that, it'll cancel itself out nicely, and you're just left with what was in the numerators. Really slick strategy. If you watch online videos or get help from someone else, you might hear this strategy as well. And it's a little bit controversial. Some math teachers don't ever mention that because it only works sometimes, and then students want to use it all the time, and then they get them wrong. So I'll mention it, but be careful. Like this is the strategy that will always work. It worked in the first one, worked in the second one. It's a great strategy. When you're solving a question with fractions, you can get a common denominator, and then you can multiply by that common denominator to get rid of it. Now, if you have a question that's one fraction on one side and one fraction on the other side, basically, what you could have done is you could have multiplied both sides by x minus 4, and can you see that that would move that x minus 4 up to the numerator on the other side and get rid of the x minus 4 on the right side? If you did the same thing with the x plus 2, it would cancel on the left side. So if I multiplied both sides by x plus 2, it would cancel on the left side, and it would end up in the numerator on the right side. This strategy is sometimes called cross-multiplying. It would allow you to go right from here, there we go, right from there to there, because if I multiply the 6 times the x minus 4, I would get 6x minus 24. And if I would multiply the x plus 2 times the 4, it would give me 4x plus 8. But this strategy only works if you have a single fraction on the left side and a single fraction on the right side. If there's anything else, like sometimes you'll get a question where there's like also a plus 1, then it's disastrous if you try to use this strategy. So for that reason, some math teachers say it's like a swear word to say cross-multiply. The students like it so much they use it too often, and they don't understand it, and then they get things wrong. Okay? I'm of the opinion, if you understand something, feel free to use it. If you don't understand it, don't use it. And this strategy is a great strategy that works all the time. Getting that common denominator and then multiplying by that common denominator works out perfect. So, we can highlight this sentence. This is on page 579. We can highlight that sentence that has a rational equation. So a rational equation has fractions. Sometimes you have x in your denominator. And you also have to look at the non-permissible values because we might get an answer that's an extraneous root. An extraneous root is an answer that appears to be a right answer, but then you find out, oh, wait a minute, that was a non-permissible value right from the beginning. An answer can't be something that's not allowed, but sometimes that happens, and that's called an extraneous root. So we'll see, it won't happen today, but it might happen in some of our examples tomorrow. So we'll go to example 1. And in part A, what I'm going to do is I'm going to leave space in front of the first fraction. I'm going to leave space after the second fraction, so I'll put my equal sign a little bit further to right here. And I'll leave space after my third fraction, because I need to get a common denominator. So I look at all my denominators, 2x, 5, and 10. I probably start with the numbers, and you see that with the coefficients or the numbers, your common denominator would be 10. So the first one needs a 5 and a 5. The second one needs a 2 and a 2, and the third one's good. It's got the 10 already. Then we look at our variables. There's an x on the bottom. First one has the x, second one does not have the x, third one does. It looks like our common denominator is going to be 10x, and sure enough, they all have a 10x, and my numerator is now, this is a 5, this will be minus 4x, and this is still a 1. Now, once you have that common denominator, what your next step is going to be, because it's an equation, right? And your rules for equations is what you do to one side, you have to do to the other side. So if I multiply this whole side times 10x, I'd have to multiply this whole side times 10x. And what's going to happen is you have to distribute here, but this 10x is going to cancel out with all of those denominators and go away. Typically what I see students doing, they don't do the green at all. They just go right to their red pen and cancel out all the bottoms. Because you're like, I'm going to multiply by 10x, and multiplying by 10x will cancel out or simplify with all those 10x's on the bottom, leaving me with just 5 minus 4x equals 1. And this is a nice, easy equation to solve. You just need to combine your like terms. So I'll move my 5 over to the other side. Divide by negative 4. And I get x equals to 1. Now we have to check if that's okay. So you can either do the non-permissible values right at the beginning. I like to do them right at the end, because then you're forcing yourself to check, is our answer still okay, or is it a non-permissible value? Are we ever dividing with an x on the bottom? Yes. Our non-permissible value is x can't equal 0. So then I often add a little check mark beside the answer that I got to show that I checked it. It works. It's not my non-permissible value. So x equals 1 is a legitimate answer. If we look at part B, again, I'm going to leave space in front of the first one. I'm going to leave space after the second one. And put my equal sign a little bit further to the right. And my answer, I'm going to leave space after that. I'm going to change that 6 to 6 over 1 just to make it a fraction. So now I'm going to look at all my denominators. I want a common denominator. The numbers are just 1, so they're going to be fine. This one is missing an x. Second one's actually got everything already. And the last one, my common denominator is going to be x squared. So then I would have 5 over x squared plus 6, 5x over x squared, plus 6 over x squared equals 6x squared over x squared. And again, this strategy is if I get a common denominator, now I can multiply both sides by x squared and those just go away. And then we get a much easier equation, but unlike the first one where it like simplified to be like a grade 9 solving equation, this is still a grade 11 solving equation. How do you solve quadratic equations? What was our strategy? Or we had like multiple strategies, but what would you do first? Make one side equal to 0, right? I personally always like to make the side equal to 0 to keep the coefficient in front of the x squared positive. So I would move the 5x and the 6 over. And this, as far as factoring, completing the square, or the quadratic formula. This might be one you choose a quadratic formula. Because having that 6 in front has two options. It could be 2 and 3 or 6 and 1. So you'd have a lot of mental math to sort of sort through. If you're like, I can't handle mental math right now, I think I just want to use quadratic formula. If you like the mental math strategy, you could try to factor it. Alright? So sometimes when I'm trying to factor it, you just choose. Do I start with 6x and 1x, or do I start with 2x and 3x? So if you choose one of them, then you have to see with the other 6, is there any way that my outside and inside can make 5 if these two numbers multiply to 6? And in this case, if I put a 3 there, you see my outside would be 9. If I put a 2 here, my inside would be 4. And 9 and 4 make 5, so this seems promising. I need a negative 5, so my 9x would have to be negative 9x plus 4x. And I would quickly multiply that all out in the end to double check to see that it all works. Split it here, this would say x could be negative 2/3, and this would say x is equal to 3/2. Non-permissible values. Are we dividing anywhere with an x? Yes, we had x and x squared on the bottom, which means that x can equal 0, so I'll put a little check. This is good, and this is good. They both work out in this situation. All right, questions to circle. 3, 4, 5, and 8.